Mira has a payload of 14 kilograms. But this is not something special. The special is the feature which is inside of her. Mira is able to have a dynamic payload. It means you can give her a little bit more payload, maybe here, maybe a little bit less here. That's actually the same as we humans do. So with the full speed, with the full reach, she has 12 kilogram payload. With a little bit of less speed, she has 14 kg payload. And the same, you can even give her a little bit more payload, and she will just tell you, hey, my reach changed. I just a little bit less reach. So let's go to the reach. She has 1.4 meter reach. That's actually excellent, because the most of the work in an industrial environment are mostly like emptying maybe some gitter boxes. Until now, the most cobots are too short for that. Mira has the abilities because of 7 axes and also having the reach. So we also have a little bit more different versions. Here you see the medium version Mira. We also have a shorter version which has just a reach of 1 meter, but a payload of 18 kilograms. The same, we also have a very long version which is up to 1.6 meters and has just a payload of 10 kg. Also, one big thing I always hear it from customers, from people which are talking about cobots. Mostly they are too slow. This is why we made the robot assistant, which is Mira, which is closer to industrial robots. So it means also has the capability to be super fast through the sensors, through the new motor concept we have. So Mira has a speed 4.5 meters per second. That's really fast. Also very special is the structure. So through this structure, we have much more stiffness in the robot, so we can drive faster, we are more sensitive. But also this structure enables actually one more thing. It is actually 7 or 6 axis robot. So it means there is just 1 axis missing in this robot there. So, and you see a lot of LEDs. It looks beautiful. I would say it would even fit next to your Christmas tree maybe. But this is not why we made all these LEDs inside. The LEDs are there to actually show you like the status of every axis on itself. So it means if one of these axes turn red or orange, so you know there's something going to be happen soon or happened already if red. And also you have many other like status. Yeah, not just the double bearing concept makes our robot super stiff and also unique. Also, we have a honeycomb structure in all these parts and a very special alloy which all our engineers developed. So this makes our robot super stiff to be able to be fast and sensitive. Also, I think everybody of you know the picture of the most cobots or the videos or maybe even in real. There's mostly cables around it, and that's the reason why, because there is mostly grippers which need different like IOs or different like interfaces on TCP. With Mira, this ends because from now on, all the connectors you need, they are here on tool center point. Here we have GPIOs like Modbus and even like IO-Link, sorry. And we have also even thought a little bit farther because in the future, I hope there is more intelligent grippers coming. This is why we also integrated EtherCAT and also CAN bus. And also very special is 3x air. This robot has everything inside what you need for every gripper which is existing on this world. So, what is more also needed to have a robot integrated into your system or maybe also in your environment? This is the safety of the robot. It's super important. To work side by side with humans, you need safety. To work maybe in a medical field by operating, you need safety. And that's why we have here a very special safety structure. Every joint on itself has own safety function, all you need to be safe. Also, we have a safe bus going through the whole robot, which sent like all the safe values to our safe master, where we calculate the safe environment, maybe safe Cartesian safety. And we have something which is super unique. This is why I think you never hear that. But we call it SHD function, the safe human detection. This enables actually that we are allowed to have a fast cobot in the environment. So now I told you a little bit about what we have, why the structure is like that. But why is it actually to be actually very accurate? Because here MAiRA is the most accurate robot on the planet, because it has like super unique new encoder design which we developed in-house. We also have very high sensitivity because there is 4 torque sensors in each axis, and also has a 6-4 torque sensor in the tool center point to decouple the forces from both sides. One is coming from the robot, the other from the surrounding, maybe from the gripper. And very high speed, because we have new motor designs, and also the structure enable the robot to be super fast. So, and we have also here the safe human detection sensor, which help our robot, or not help, it's a wrong word. It's actually, it makes it really safe, because it knows the environment and it knows if there's a human coming into. So it distinguishes human from other objects. And we have many other modular sensors which are located in the head of MAiRA. And many IMUs and temp sensors to make all this function real. So it means to be more accurate, maybe also more sensitive. So let's start to explain a little bit more about the head of MAiRA, because there is a lot of sensors inside, even does not look like it. So here you see the HMI buttons. You can configure them just on the graphical user interface. You can even have several pages of programming like actions here inside of the small buttons. Also, we have a 3D voice sensor. So it means a microarray to make our robot able to hear the surroundings, also to interact maybe with me. Also, very unique is the touch skin. That's something I will explain you later, but our robot feels when I touch it and also where I touch it. 3D vision sensor. A camera is inside, and we don't see just the color, or we don't see just 2D. No, we have 3D camera inside. We also see the depth information, a 3D point cloud, which is transferred to our control. We have a 6-DOF force torque sensors, which is here integrated in a TCP, which make our robot able to feel very, very sensitive and precise. So everything what you saw here, maybe you don't need a camera. Here you're able to just let it out. So it means this MAiRA structure will be always the same. The only thing is modular is actually the head part. So you can just leave the camera away. So let's come to the best part, actually the fun part, I would say. Really starting to interacting with a cognitive robot. So here you will see what's the biggest advantage of being cognitive. So all these senses are there to also perceive the environment, but they are also there to interact with you in person. So every person in the world has a different kind of communication, or like a different way of communication. The same also, every person like to program this robot on a different way. And for that we created 6 different ways, and even more. by combining them. So first we have the teaching by grabbing the robot and just maybe moving to some position to teach. There's also record functions where you can record complicated movements or record movements by gluing something. So there's also recording on forces by grabbing the robot, moving on some direction, and also recording the forces which is coming from the side here. There's also like action recording, so it means everything you're doing is getting recorded, and that's great. But there's also, I think, the most fun part, which is the voice. Because we are humans, we like to interact by talking to each other. And that's the same with Mira. Mira loves when I talk to her. You will see later. I mean, there's also gestures. Like the Italians, I think they like this one the most. By showing something, she understands. And also, there is a way, which I think the young guys like maybe, by just a tablet. I mean, even my daughter knows how to program this robot, I'm very sure. I will show you. This is the tablet with the graphical user interface. So let's just start the robot. Now you see the digital twin of the robot. I hope you see it now. So here you can just go there and actually touch any axis. From now on you can just move the robot in each direction which you want. Or you go over to use other moving functions like zero gravity. So I turn the robot on. From now on I can actually move the robot wherever I want. Here you can also record these actions, what you want to do. But I have not much time, so I just go very fast through all of them. How to program actually. You go inside the program. Here we have already some pre-programmed versions which you see on the right side, but you can also just create a new. Here you will be also asked, you want to code, like the last action, or you want to program over tree editor. So how to program over tree editor. Here you just go grab the gripper you are using, and now you can just everything over drag and drop. You can have any action, just drag there and start it. So, but I want to show you also some different actions. One I showed you very shortly is actually the zero gravity, which you can have like the whole robot in zero gravity and moving in any direction you want. But there's also some disadvantages because this action has, this robot still has some rotating axis. So it means it's very difficult to get linear, like maybe on some road. So this is why we implemented also something which we call the skin. It's a 6-DOF touch skin, which I can activate here. And from now on, the whole robot, you can just, over this touch skin, you can move the whole robot. And very precise actually in any direction, but now linear. So it means you can X, Y, Z. You even have some turning directions. Everything very simple over this skin and also very precise. But the other big advantage is actually that you can, you can actually divide the forces. So it means over zero gravity, it's very difficult to see where the force is coming from. Are they coming from down there? Are they coming from the robot? So this is why, to be precise in force recording, we decided to put this sensor inside. And also having a force torque sensor, which is here always integrated in TCP. For example, grinding application. I mean, I think nobody ever seen something like that. When you're taking the robot, you can actually put in the number of pressure, like in forces, and the robot will just apply this kind of forces which we want to apply to. So, and there is something which I think you all, because I was talking already so fast, I love to talk. So this is why I activate now my favorite part. We call it the voice
commanding is ready.
Hey Mira.
Hi David, what can I do for you?
How are you first?
You know what? I feel shy in front of all these cameras.
Me actually too, but I'm getting more and more
What can I do for you? Please use "Hey Mira" before each command.
So now everything I say she hears, so I have to be carefully. Hey Mira.
Hi, what can I do?
Free drive mode.
Do you mean free drive mode?
Yes.
I'm in free drive mode now.
So now you can take the whole robot and move in any direction. And stop. You can also give her other commands like, hey Mira.
Hi, what can I do?
Move join.
Do you mean move joint?
Yes.
Move joint to which point?
28.
Do you mean 28?
Yes.
Move joint to point 28.
Here you see, you can command her with everything. And that's amazing. That's something what I love the most. You can even turn some axes if you want. You can do many things, and this just like how we are used to communicate with humans, and that's also how you can communicate with our robot. Like I told you, we can program the whole robot by voice. So when I say, hey Mira,
hi, what can I do?
Record actions.
Do you mean record actions?
Yes.
I am in free drive mode and record your actions.
So now you can move the robot and tell actually, okay, and swipe just over here.
Point saved.
And make some points where you want to go.
Point saved.
You can even
point saved.
Even close gripper.
Gripper close.
You can open the gripper.
Gripper open.
And make a new point.
Point saved.
Now we made a new program. So stop.
All actions saved.
Mira. Hey Mira.
Hi, what can I do?
Play.
Now I play the last trajectory.
So now you see exactly what I was moving, and she just recorded everything. Even now you will see she will open and close the grippers like I did. So that's actually the new way of programming. This is like an interaction of different kind of disciplines. One is by hand guiding, one is by voice, and the other is even over the safety, the touch skin. I'm sorry. So now we will come to the other part, which is also fun. This is actually the vision part. I mean, I think the most of you know that there is cobots, and you just integrate a vision system somewhere on some corners or whatever. And the very big difficulty about it is actually to integrate them, to make them cooperate together. This issue you will not have with MAiRA, because MAiRA has all the vision sensor and everything inside the robot. Here you see the camera, and I will show you some example for it. So now I place some parts on this place. And so there is two different or many different kind of vision applications you can do. I mean, there's one, it's like object detection, there's like identification, and also pose estimation to know like where it is and also how to grasp it. Smart grasping and also smart assembling task possible with this vision. So in this case here, what I would like to show you is actually first we have also some machine learning algorithms which are running on our system. So we have integrated GPU and CPU, which is very strong to also make machine learning directly on the robot. I start with a simple task which I call just program scan. So here I just run the whole to show you how easy it is to scan the environment and also then learn out of it. So now you will see the robot is going to move. And this movement now, actually, he captures everything what he sees, but you will see it also in the GUI. I hope you also see the GUI at this time right now. Here you see, in one hand, is the point cloud, which is actually the depth information which the robot gets, and also actually for later for the learning process. And you see the 3D images to actually also save them, because we have two kinds of, one is 3D images, like, color images, and the other is point cloud. So now we are loading and processing the whole part. It will also take some time, but then we are able actually to learn out of it. So at this time he goes in a different position, and afterwards you will see that you get like this, what we saw here in the real environment to the virtual environment. So here, now you see it on a GUI actually, that we have now this environment, like this components which you see here, also in our virtual environment. So now we could actually just disconnect this tablet and make actually also some simulations in the Unreal environment. So now we saw one thing, but I show you also something even also cool. And that we call pick objects, which we learned. So right now we have two different kind of picking of objects. One is actually unknown parts. So I can put any parts on this table, and Mira will actually take every part away which is there. It will always find a way how to do it. But there's also another, it's actually selective grasping. So that's what I'm now turning on. Now you see, she actually recognized two of the parts which she learned before. So it means in this moment, I can actually click on one of them. I like chips right now. And at this, like in this moment, you can also choose how many of these components you need. So can you imagine, like for the industrial, you have like many kind of components in a box. You first put them there, learn them quickly, and then grab them out of the box. Or also, like the future of any supermarket. We are all having a smartphone. We have an app where we just type in what kind of components or what kind of like food or groceries we want. And in this moment, Mira is going through the store by the vision and picking all these parts, which all these groceries, I'm sorry, I'm very industrial, and groceries, and put them in a basket. So you don't waste time for it. You're just going and grabbing the whole basket for you. So one of the other cool parts is actually grasping objects, known, unknown, it doesn't matter. For that, we have the picking function. When I run the picking function, she will actually now check the place of all objects and now decide for one of these objects. And she's able to pick any kind of objects. It doesn't matter if they fit inside of the gripper. So at this moment, she chooses actually the Pringles, what I would actually do. Sorry, chips. But I think she decided for the Pringles. Yes, awesome. So now she takes the Pringles and actually bring it to the other side. So I just thought. So that is actually one of the functions which you saw before. You can have picked function. You can also have unknown function. Can you imagine, like for your environment until now? I mean, until today, the most applications are with the additional cameras. And the additional camera is actually has to be connected to your robot. The environment is so important. And also, other thing is that the robot on itself actually does not need any other parts or QR codes or something like that to know actually the environment. So it will just calculate the whole environment by the own camera and how the camera is calibrated. And for that we have also extra tools. So I just stopped because she will now start to pick any of these objects. Yeah. So there is also some other features with the camera. One is like the scanning environment. One is actually knowing, like picking parts which you don't know. But there's also some others like gesture. And therefore we have one camera, yes, there on the front, but we also have implemented 3 different cameras. So at this point, when I show like pushing my fingers together,
Point recorded.
it will save the point. And the same with many other actions. But because of time, I'm just going to right into one of my favorite features. I had a lot, I know, but they're all like the best features you can find. So I'm just choosing one of the programs because I have to put the point inside. So now when I play it, it has to actually start. You see the robot is working. So I go some steps away because then you will see also how the robot gets always faster and faster. This is one of the coolest features you can find. This is actually the feature which makes the robot fully collaborative. Something which will not collide with humans. Something which will not hurt you. And a cool thing you will see here. When I go closer, he goes away. But now, actually, I go a little bit away. He will go again and start going faster and faster. I tried a little bit faster, like now. It will not. It will stop again. But he goes as close as possible. So even here, it goes as close as possible, but it will normally not touch me with all, because we have even a gripper inside the system. I go again a step away, it goes faster again. But now, look, because this is a road which is always safe. So it means it does not depend what you have into your gripper. It does not depend like on what you're handling. It is actually just sorry, the word. It depends on just as soon as closer you come, the distance of each body part of Mira is actually important on the distance to the human. It will also not function if I threw something else inside, because we know also the function like with the scanners. The scanners are actually there. They will detect anything what is actually moving, but Mira detects just humans, and that's so special. And how does the sensor work? Actually, we will not tell you. The thing is just, it is redundant and is also diverse, where we also certified as a CO3 component. Yes. Also, I forgot maybe in the beginning, is actually that these cameras which you see there, they are not depending on this function which I showed you right now. But they are actually able to also check what kind of objects you have on the TCP. So it means even there we can have the first fully machine, because until now the robots are not completed machines, and that's actually a disadvantage, and that's why you need so much time for all the certification processes. So like you see here, it will not move at all because it knows that I'm there, and from any angle you can go, it will always see you're there. So now you see I showed you like a lot of functions. Or why did we do it? Actually, to invite you first to come here to meet this amazing product, and also to like get some new partners maybe which are outside, which want to cooperate with this amazing product, which we call Mira. So there's one more thing I really need to tell you before I have to be there. So this sensor which you have now seen, the safe human detection sensor, will be in all our systems. So it means every of our robots will be in future one of your personal assistant and is always safe, even without touching you.